Hey guys, Mr. Kelly here. Just going to go over the answers to the practice test 2. So I've just imported this test and it looks like a few of my things have moved around. You can see my cone is up the top right there. So a few of my questions might just be a little bit different to yours in where they're positioned, but I think I've got most of them. All right, so we're going to start with question 1. We've got to find the total surface area of a pyramid and a cone. I'm going to start with the pyramid. Okay, so what I'm going to do is I'm going to just draw a line down the middle to separate it. 2 questions. Cool, so we've got a pyramid there, guys. We can see, so that if we're trying to find the total surface area, it's going to be the area of the 4 triangles up the top of the pyramid. Okay, and then we're going to add the rectangle on the bottom. Okay. If you look closely, guys, you'll see that on the base of our pyramid, so along here, all right, we've got 13 as one length, okay, and we've got 12 as another. Okay, so it's not a square base pyramid. Okay, so we're actually going to have 2 pairs of triangles up the top that are actually a little bit different in size. Okay, because of that base length being a little bit different, the 13 and the 12. Okay, but we're going to have 2 pairs of each of those triangles. Okay, so what we're going to do is we're going to start with the first triangle, the one where we've got the slant length, the 18. Okay, so it looks something like this. Okay, we know the height is 18. Okay, we know the base is 12. Okay, and if we find out the area, so area equals half times the base times the height. It's going to equal half times our base, which is 12, times our height of 18. Okay, and that's going to get us the area of one triangle. And because we've got 2 pairs of that, I can times that by 2. Effectively, these will cancel each other out, the half and the 2. So it'll be 12 times 18. Which I've got as 216. All right, that's going to be centimetres squared. Okay, so that's our 2 triangles. Now, if we think of our other triangle there, guys, we've got a base of 13. Okay, but we don't know this height here. Okay, so what we're going to have to do is we're going to have to find that height. Okay, I'll draw it on our pyramid. It's that length there, which we don't know. I'll put it as X. All right, we can use Pythagoras' theorem to find it, though. What I'm going to do is I'm just going to move a bit to the left. So up in the top left here, we're going to work on just trying to find that slant height. Okay, if we start with part of our triangle that we do know, we know with the first triangle we found that the slant height was 18. Okay, and if the length across, okay, this length again along here is 13, okay, we're going to use that to help us find the height of the triangle. So we're going to need the height of the triangle to find that X slant height, okay? So that 13, though, that's not the whole length across the base of this. Okay, that's only going to be half of it. Okay, so that length is going to be 6.5. All right, and we're going to be finding the height X. Okay, so you guys have done lots of Pythag. I'm sure you're all great at it. So it's C squared equals A squared plus B squared. Okay, so we're finding the height of the pyramid. Because we're going to need that to find that slant height. Okay, so that's going to be 18 squared equals, I'll use A as 6.5 plus B can just be X squared. All right, so 18 squared is 324. And 6.5 squared. So guys, if you used 18 is a slant height. For the other pairing, you'll be slightly off, not far off, but just slightly off. It's a little bit different. Okay, so what I'm going to do here, guys, is I'm going to minus the 42.25 to the left side. Okay, so it leaves us with x squared is, and I'm going to do 324 minus that 42.25. Okay, that gets us to 281.75. Okay, and then to find the height of our pyramid, square root that. It's going to equal 16, and I'll leave some decimals just because it won't be our final answer. I'll leave 4 or 5. 16.78541. Okay, so guys, if this was a square-based pyramid, you could just go ahead and find the area of one of those triangles up the top, times it by 4. But in this case, we've got different dimensions on the bottom. So we've got to find the slant height of the other pairing of the triangles. Okay, so we've got this pyramid height is 16.78 and so on. Now what we can do is we can actually draw, I'm going up here now, is draw another triangle. Okay, and it's this triangle in here. So I'm on the pyramid. Okay, so length on the bottom, the height of the pyramid. Okay, and then we're going to find the value of x. That's slant height. Okay, so I'll draw that up here. Imagine it looks something like this. Okay, we know the height of our triangle, 16.78541. And if we think about this blue length here on the bottom, okay, that's going to be the same as, half of the 12. Okay, so that base length is going to be 6. Righto, and our slant height is x. Okay, so again, we use Pythagoras' theorem. Okay, the value of c is x squared. 6 squared plus 16.78. Okay, so I don't really expect this slant height will be far off 18. It's going to be a little bit different. So I'm squaring the 6's, and I've got to square that. 16.78541. Gets me to 281.79. 74.9988. That'll be enough decimals for it to be significant. Okay. Pretty long-winded question. Okay. If we add those together, all right, and then square root it, so we're going to add the 281 point whatever plus the 36. All right, square root that whole answer. 0.749988. Okay, I get the value of, okay, so that slant height is not quite 18. That slant height is 17.82. And again, I'll go to a few decimals because it's not our final answer. All right. So, a bit of a tricky question, the first one up. Okay, we know that slant height is 82554. Okay, so what I'm going to do is I'm going to go back to that triangle we were working on before. I'll get rid of the whole thing. I'll draw it again. Okay, so the base of the triangle is 13. And the height, rather than me writing it in, the height is that 17.8. So we just found. Okay, because there's going to be a pair of those triangles on the front, one on the back, we're going to times it by 2. So the area of a triangle is half times the base. times the height. Cool, and as I said, we'll times it by 2 because we've got two. We've got a pair. Okay, so it's going to be, again, the half and the 2 are going to cancel each other out. So it's going to be the base times the height. So it's going to be 13 times the 17.82. Oh, 82554. Okay, which equals 13 times 17. So a bit of a spanner in the question, guys. We didn't get a square base pyramid. If it was a square base pyramid, we could just find the area of the 4 triangles, but that area is 231.73, and I'll do 202. Sweet. So we found all the triangles on the top of our pyramid. The last thing we've got to do, guys, is we have a rectangle on the bottom. I'm going to move down to the left here. A bit all over the place. It's not quite these dimensions, but it's going to be 13 on one dimension and 12 centimeters on the other. Okay, so to find the area of this rectangle, guys, just multiply the 12 by the 13. So the area equals, you know your 13s times tables, 156 centimeters squared. Cool. All right, so what we're going to do is if we add the values we found to the 216, oh, please don't stay there. Please don't move with me, I mean. Add the 216, add the 231.73202, and add the 156, we get a total surface area 231.73 plus 156. Cool, add it all together. The total surface area we've got is 603 and 2 decimal places, 0.73 centimeters squared. Cool. So that is our total surface area for A. Okay, so big question to start with. Please stay over there. I wish that thing would stay over there. Oh, whatever. You know the answer now, 603. I'll move over to the left. I'll just keep moving it. Question A or B, or the cone anyway. We've got to find the total surface area of the cone. Okay, we've pretty much got most of the information we need. If we write out the rule for a total surface area of a cone, okay, it is pi r squared, it's the area of the circle on the bottom, plus pi times our radius times the slant height. Cool, so if we look at our cone, guys, the only thing we don't know is we don't know our slant height. Okay, again, we can use Pythagoras' theorem there though. Okay, so I'll just draw my own triangle. Okay, that length to the middle of the cone is 4 meters. Okay, we've got a height of 8 meters. Okay, and we're trying to find the slant height. Cool, so if you use Pythagoras' theorem, c squared plus b squared, it's going to equal s squared equals 8 squared plus 4 squared. Cool. You've probably done so much Pythag that you're sick of it. 8 squared, 8 8s are 64, plus 4 4s are 16. Add 64 and 16 is 80, which is s squared. Okay, and then to find the value of s, square root both sides. So it is the square root of 80 which is 8.9. And again, I'll use a few decimals just because it's not our final answer. Just to be safe. All right, I'll go to that many. Cool. So we've got our slant height. All right, what I'm going to do is I'm going to use that now and input that as our S for the total surface area. Cool. So our total surface area becomes, so using that rule just left, so pi times 4 squared plus, I'll just move over if I can, plus pi times 4 again, times our slant height of 8.94427. Cool, so we get a total surface area of pi times 4 squared. Cool, so again, guys, make sure you're doing as much working as you can, just so you don't make mistakes. Plus pi times 4 times 8.9427. Righto, so I get the total surface area. I have 162.66. And that's meters squared. Do that in red because it's our final answer. Sweet. First 2 questions done. All right, moving on. Question 2, using the cone to the right, find the slant height of the cone. Cool, we've just done that in a previous question, so this one is going to be easy peasy, Japanesey. Yep, so we're going to be finding the hypotenuse, the slant height. We know the top of our cone is 5, our radius. Our height is 14. Cool, so we're going to be using Pythagoras again. Lots of Pythag. All right, by now, my S's and my 5s look similar. Sorry about that. But by now, 14 is that 160? I should know that. 196. Cool, so if I add 25 and 196 together and then square it both sides, again, just make sure on your calculator you add them together first, especially those green calculators, because they don't factor in bod mass or bid mass. However you like to do it. So 196. Or maybe they do. I'm not sure. I think the green calculators can be a bit pretentious, but 14.8 into 2 decimal places, 87. And that's just a slant height in meters. Cool. Awesome. All right, moving on. Now that we have that slant height, we're going to find the curved surface area of the cone. Okay, going back, guys, looking at our total surface area rule here. Okay, we know that the pi r squared part, that's the base, the circular part. So the pi rs is going to be the curved surface. So I'm going to I'll write curved surface is going to equal pi times our radius times our slant height. Wasn't it? Yep. Just making sure. Cool, so that's going to be pi, a radius of 14 point... Ooh. Maybe I should add some decimals. I won't use our full answer. I won't use the rounded answer, just to be super duper duper sure. 0.6, that'll be enough. Times, I put our slant height first. Our radius was 5. Okay, and that'll get us the curved surface area. I love measurement. Such a good topic. Times 5. So visual. Cool. So that is 233 point. Hopefully I'm rushing through. Hopefully I don't make a mistake. And that is in meters squared. Here's our answer. Sweet. All right, there's no other questions? Nope. Volume of a cylinder. Volume of cylinders and prisms is easy, guys. You're just finding the area of the face of the shape. Okay, and then just timesing the height. So if we have our first cylinder, the area, what am I saying? The area, the volume is going to equal the area of the face of the shape, so the circle, and then we're going to times it by the 10. Cool, so the area of the cylinder is, not in green, let me use black, is pi times radius squared. Okay, and then we're going to times the height. Okay, just working down from that pi. Our circle radius is 4. Our height is 10. Cool, and that'll get us our volume. So pi times 4 squared times 10 equals 502.65. That's centimeters cubed. All right. B, we've got a rectangular prism. All right, so this one should be easy peasy, guys. We've got a face, which is a square, so it's going to be 5 squared. Okay, and then times the 10. All right, I'll just quickly do it. Volume's going to equal the 5 squared, because it's the 5 times the 5. All right, times the 10. Okay, 5 squared is 25. Times 10 should be 250 centimeters cubed. Cool. All right, moving on. Volume. All right, we have a triangular prism now. In this instance, the face of our shape, imagine the face, you can push it all the way through the shape. All right, is this one here. Just colouring it in. Okay, so that's a triangle. Don't be fooled because it's on a slant. Even if it's on a slant, the area is still applying the same rule. Area equaling half times the base times the height. Cool, which is 1/2. Times our base is 24.5. Times our height, 18.3. Okay, that'll get you the area, which I'll quickly do, of the triangle. Times 18.3. Okay, which I've got as 224.175. Okay, and then I'm going to times it by the height of the shape, which is here. So that's the 21.2. Which we get a volume of 4752.51 centimeters cubed. cubed. Cool. Right, question 3. We've got a cylindrical water tank. Okay, it's got a diameter of 1.7 meters and a height of 3 meters. What is the capacity in liters in the tank? Okay, so what I recommend, guys, is if you get a worded question, okay, that you always draw a picture. Okay, so I'll do that now. So we have a tank. That is the worst tank ever, but it'll do. It's a water tank. We've got a diameter of 1.7 meters. Okay, so if you halve that, guys, that's going to be the radius. So that's 0.85 meters. And we've got a height of our tank of 3 meters. Apologies again for my terrible water tank. All right. So, what we're going to do is to find the capacity, guys, we've actually got to find the volume first. Okay, which is in meters cubed. And then to be able to convert that, I'm pretty sure meters cubed is liters. Is it? No, milliliters cubed. So we might have to times it by 1,000. Let me get up. I forget. Let me get up my conversion chart. So we're converting from meters cubed to liters. Yeah. So 1 cubic meter equals 1,000 liters. So we're going to times it by 1,000. Cool. Anyway, do one thing at a time. We're going to find the volume of our water tank. So it's going to be pi times radius squared times our height. Okay, which is pi times 0.85 squared times our height, 3. Okay, and that equals pi. So the capacity stuff, you should have covered last year in your measurement topic. I know 9E, we definitely covered it when I had you guys. 6.809.402. Okay, that's meters cubed. Okay. And meters, to get from meters cubed to liters, guys, what you've got to do is you've got to times it by 1,000. And that'll get you the liters. Okay, if you think about when you times something by 1,000, you bring the decimal place 3 places to the right. So it's going to be 6,809.40 liters. Cool. All right. Question 4, find the volume of the following. So those shapes, guys, we've got a cone and we've got a square base pyramid. Okay, we've got to find the volume of it. Okay, so we've got a cone first. Might start with that one. I'll divide it by 2. That cannot be B, and this can be B over here. So we're going to start with the cone. To find the volume of a cone, it's pi times our radius squared times our height on 3. Cool, so that volume equals, and I think we've got all our information. We've got the radius of 5 here, and we've got our height of 14. So we don't have to do anything. We can just put it straight in. So pi times 5 squared times 14 all on 3 will get us our volume. Cool, so I'm just putting this in my calculator. Pi times 5 squared times 14 on 3. Okay, gets us a volume of 366.5, rounded to 2 decimal places, 52 meters cubed. Cool, so that is A, which I used as the cone. B, we're going to do our pyramid. Okay, so what I'll do is I'll write the rule for the volume of a pyramid. The volume equals the length times the width times the height on 3. Cool. Okay, so in this case, if we look at our pyramid down the bottom left there, the length and our width, because it's square base, is the exact same. Okay, so it's going to be length times the width, 4 times 4, or 4 squared, times the height of our pyramid we've got is 6, on 3. 4 squared, 16 times 6, 96 divided by 3 is 32 meters cubed. Cool. All right, moving on. So we're still finding the volume of these shapes. In this case, I've got a pyramid on top of a cube, and then I've got a sphere. Okay, so I'll divide it into 2 again. I'll do them here. This can be C. C I'll do as the composite shape. D can be the sphere. All right, so to find the volume of a cube, that's going to be the length times the width times the height, which in this case it's just all the same. So length cubed plus the volume of our pyramid. Okay, so we just did that. It's length times width times height on 3. Okay, the length is still 6. The width is still 6. The height is 5. That's going to be on 3. Okay, so I just did a lot. I did at once. But if you find the volume of just the cube first, that's going to be 6 cubed. Okay, and then it's going to be plus the length times the width times the height, so the 6 times the 5 on 3 of the pyramid. Cool, so 6 cubed gets us to 216 plus 6 times 6 times 5 on 3 gets us to 60. Okay, add those together is 276 centimeters cubed. Cool. Moving on, so we're going to do that sphere there. We've got its radius of 40 centimeters. Okay, so to find the volume of a sphere, which you guys will be working on this week, it's 4 on 3 times pi times radius cubed. Okay, and we did have our radius. That was 40 centimeters. Okay, so the volume is going to equal 4 on 3 times pi times, wait, did I say 40? Can't remember. Yep, 40. Cubed. Cool, so you put that in your calculator. You maybe just do it in parts if it doesn't quite work out. But 4 on 3 times pi should all work because it's all, unless it times the 40 before the cube. 40 equals, in centimetres, what have I got? 268,082.57 centimetres cubed. Cool. Oh, just a bit there. All right, how many questions we got left? Only a couple left, I think. Yep. Nearly done. What I've got to do, find the surface area and volume of a sphere with a radius of 5, correct 2 decimal places. Okay, this is the same question as just the one above, except this one it wants the surface area as well. Okay, if you do want to actually draw a picture, got your sphere with a radius of 5 centimetres. Cool, so you're just doing 2 parts here, guys. You're finding the total surface area. All right, and what that equals, and you're finding the volume. And what that equals. Cool, so a sphere, again, you'll be working on this week, is 4 times pi times radius squared. So that equals 4 times pi times 5 squared. Cool, so 4 times pi times 5 squared equals 314.16 centimetres squared. Okay, and then the volume, we just did an example before, okay, of that rule. So 4 on 3 times pi times radius cubed. Okay, which equals, I'm running out of room, 4 on 3 times pi times, we had a radius of 5, was it? Yep. 5 cubed. Sweet. 4 on 3 times pi times 5 cubed equals 523 point. Okay, I've got 0.598, so that's going to round up to 0.60. What unit were we using? Centimeters. Cool, centimeters cubed. Ah. Oh no, please stop there. The volume of air in a sphere is 100 centimeters cubed. Find the radius. All right, guys, so this is just the same thing, except we just know the volume of the air in the sphere. Okay, you can always start by writing out the rule for a sphere, so that being 4 on 3 times pi times radius cubed. Okay, and the parts we know, okay, we know what the volume is, that's that 100. Okay, the part we want to find out is the radius. Okay, so we're going to be using a little bit of opposite operations to get R by itself. Cool, so what we'll do is we'll fill in the stuff we know. We know the volume's 100. Okay, and it's going to equal 4 on 3 times pi times our radius cubed. Okay, so what we're going to do is get R by itself. Okay, so all I'm going to do is I'm going to start with the 4 on 3 and just times the pi alone. and just find out what just that part equals. So 4 on 3 times pi. Okay, equals, hey.
Was there students in here?
Nah, we've had it, it's been sprayed down and everything. Okay. Yeah, thank you. Cool, so that was 100 equals, and I've just done the 4 and 3 times the pi. So 4.18879. Okay, times our radius cubed. Okay, so to get r by itself, I've got to divide this 4.18879 on both sides. Okay, and that's going to get me r cubed by itself. So I'll do that now, 100 divided by 4.18879 equals 23.87. I'll go to 5 decimals, so 324. Okay, and then to get radius by itself here, guys, is you have to cube root. Okay, which on your calculators, I'm not sure how to do it exactly on the green calculators. I've got to work out how to do it on mine. To cube root. It might have to press control something on your calculator. Essentially, you're going to put the 3 in front of the square root sign. So instead of being a square root, it's going to be cube root. Cool, so I found out that radius. It equals 2.88 centimeters. Sweet. All right, guys, we've got one question to go. What have I done? 42 minutes. Wait, was that the last question? Just to 2 decimal places. Oh, that might be it. Cool. I think there's nothing else. Hopefully I've got everything. Righty, guys. Good luck with your test when you return. Hopefully this helped. Overall, good stuff with doing measurement at home. All right, really looking forward to having you guys back at school. Okay, bye-bye.